Yeah, hi there. In this time series tutorial, we are going to cover moving averages. So, considering that the last observation in a time series, it has more impact on the future rather than the earlier versions or the earlier observations. So, in the simple moving average technique, we take the average of only the last few observations to forecast the future. So, that's the basic principle of this simple moving average technique. So, in a simple moving average technique, the overall uh, idea is to take the recent data, take the average of it, and using that we forecast for the future. So, because uh, the belief is that the recent data will be the true representative of the nearby future. So, instead of taking the entire data set and then making a prediction for the future, let's take only the recent data set of a reasonable sized window, and using that then we do the forecast. So moving average is a technique so to get the overall idea of the trend in a data set. It's an average of any subset of numbers. It is extremely useful for casting the long-term trends. So what we do, we calculate an average of a period of time, and based on that we forecast it. For example, if you see in the stock market, we generally use 50-day or 200-day moving average to see the trends in the stock market, and based on that we forecast the stocks prices ahead. So in terms of formula, this is how the simple moving average looks like. So the forecast value at time t plus 1, it is made at the time t, which is equal to the simple average of the most recent m observations. So what it means, that if we have to forecast for a period t plus 1, so the forecasted value we are representing here as y hat t plus 1, this is the forecast value. So this will be equal to the average of most recent M observations. Now M is subjective, that depends on our business case, whether should be small enough like 3 months, or it could be 6 months, or it could be 1 year, depending upon how our business problem is and how our data set looks like. So what happens with this simple moving average? It actually captures the trend, and if we slightly reduce the window of the simple moving average, then it can also capture somewhat the cyclic part also as well. But what we basically lose out in the simple moving average is the seasonality within a period. And also we would observe that there is a lag in terms of the peak and the trough. Okay. Now, so there is actually also a trade-off between the window that we choose. For example, if you are choosing a very short window, it means that you are allowing noise to pass through into your model. And if you're taking a too long window, then it means you won't be able to capture the cyclic pattern in your data. So there's a bit of trade-off that we have to maintain, like the window should be reasonably sized so that it captures the cyclic part as well, and without having too much of noise in it. So let's take an example. So again, we are just importing our libraries NumPy, Pandas, Matplotlib, and Seaborn. And so the same example that we had followed in the previous session. So I'm just reading from the airline traffic .csv data, setting up the columns month and passengers, converting the month column to date time, and setting that month column as an index. Some of the missing values are there in the passenger columns, that I'm interpolating it using the linear interpolation, and just making the passengers as integer type. Now I'm just splitting the data into train and test. So the train contains data from index 0 to 119, and from 120th index onwards it is in the test data set. Now what we are doing is we are doing a simple moving average calculation for a 12-month window period. That is, I'm taking 1 year of data, that is 12 months of data, taking the average of it and using it to forecast for the next month. And in this way we are gradually moving our window of 12 months in the forward direction, and we keep on predicting for the next month. Okay, so initially what we do, we have taken the entire data sets copy in y hat SMA. Now window is our 12 months. So in this y hat SMA, we are creating a new column SMA 12-month forecast. So simple moving average based on the window of 12 month and forecast. So what we have to do from the original data frame, I'm using the passengers column and then calculating the rolling average with a window of 12 months and mean represents the rolling average. Now the thing is, for the test data set, uh, the forecast value would be equal to the last observed value or the last forecast value of the trained data set. So using this, I'm adjusting the all the values which belong to the test data set. So in the y-head SMA, from the location, that is from the length 120th, index 120th onwards till the end. The first column represents this SMA 12 month forecast, that the value of this particular column should be set equal to the last observed value of this forecast value of the trained data set. Now, since we are storing the values in the same y hat SMA, so I'm just going to the index location up to the length of train dataset, whatever it is, and extracting that particular value for this column SMA 12 month forecast, which is at index 1, and storing it. So basically, the idea is all the forecast of the test data set would be equal to the last forecast that we had seen up to the index where the train data sets data train data sets was having the data. Now we have to calculate the error part. So again, we are just calculating the RMSE and MAPE. RMSE, as you know, it's the root mean squared error. That is uh, which is the square root of the mean of the squared error, and MAPE is uh, mean absolute percentage error. So we are taking the absolute error and just dividing it by the actual data test data, and then taking the mean basically and multiplying it by 100 to get the mean absolute percentage error. So RMSE and MAPE for this simple moving average method of 12-month window is coming as 103 and 15. Now we have done this for a 12-month window, and let's see if we plot it. So we are just plotting using the train test and our 12-month forecast. So if you notice that we have done the 12-month forecast for the entire using the entire data set. That is, we want to see how exactly our forecast looks like also for the train data set, not only for the test data set. So this is the blue color is the train data set. The green color line is the simple moving average forecast, keeping the 12-month window, and this is our test data set. So if you see, our forecast is able to capture the trend because the original data set is having an upward trend. The same upward trend is also shown by this SMA forecast, simple moving average forecast line. What it is not able to capture is the obviously the seasonality, because if you see within a year there is a lot of seasonal pattern which obviously is not being captured here. Now we can alter the window. Let's say if we change the window from 12 months to the 6 months. So what I'm doing, I'm just changing the window of 6 months and again calculating the rolling average with this window of the 6 months, storing the values in another new column, which is SMA 6-month forecast, and rest of the things are same. That is uh, all the values for the test data set would be having the last value as observed for this train data set based on the forecast. And again, we are just plotting it out. So if you see, this is the blue one is the train data set, and the green one is the SMA forecast considering the 6 months period. Now, if you see in this case, we have reduced the window. So because of which this time our line is not flattened. It is having some sort of pattern as well. Okay. So, and compared to earlier, we were forecasting very less, that is undercast, but here we are forecasting somewhere, somewhere towards a higher value. But the good thing is that we are able to manage some sort of trend like we were doing earlier, and at the same time, some sort of cyclic nature and some sort of seasonality as well using this 6 months forecast window. Now, if we calculate RMSE and MAPE just to do one-to-one comparison between the 12-month window model and the 6 month window model of the simple moving average, we notice that RMSE has come down to 90. Earlier it was, I think, yeah, 103. From 103 it came down to 90, and MAPE from 15 came down to 12.96, roughly 13. So it means this model is that is the simple moving average model of 6 month window is better than the simple moving average model of a 12-month window. Now, what I'm doing is I'm just taking one more window of 3 months period. Let's say if we reduce the window to 3 months, that is from 6 to 3, what happens to the model? So again, it's the same thing, just changing the window to 3 and again calculating the rolling average, storing it in another column, which is SMA 3 months forecast, and again calculating the RMSE and the MAPE, we see that the RMSE and MAPE, the both have increased considerably. Now RMSE is 138, whereas it was 90 for 6 months window. For 3 months window, it is 138. So what it clearly suggests that if we uh, narrow our window too much also, then what we are doing is we are allowing too much of noise to pass into the model, and obviously our model will deteriorate with too much of noise. So we don't want our model to deteriorate. So obviously we cannot take too much short of a window. So that's what the trade-off is. So that is, we want a window which is good enough or reasonable enough to capture the trend, cyclic pattern, and some sort of seasonality, and at the same time with lesser amount of noise into it. Now let's see if we take the 9 month window, what happens, because earlier we had taken 12 months, then 6 months, now 3 months. Now let's take one more window of 9 months and just see how it looks like. So if I take 9 months window, RMSE is 94, better than 3 months, but if I compare to the 6 months, then it is not better. Now, again, the simple MAPE is 13.58, which is better than 3 months, but not better compared to the 6 months. So what we found that for simple, for this particular data set, we are able to forecast better if we take a simple moving average of a 6 months window. So in this way, we see that using these moving average methods, we can make a better forecast compared to the earlier methods that we use, like naive method. Okay, so the important point to remember is the size of the window that we have to choose, which should be reasonably good enough so that we can capture the trend, obviously, and some sort of cyclic and the seasonal patterns, and without introducing too much of noise into our model. So that's it for now. Thank you.